just fold it over, and then I'll save it when I get back to my office.
Why does it miss it? Who takes it?
I actually took it by accident last time, because I usually bring my own, and then I forgot to bring it back over. So, it's my fault. But at least I know I'm going to bring it back. Eventually.
I sailed my first Texas one, and I was like the most hard. Since then, the only one else, but. Well, that's the thing. I got all A's in her classes. So. How's that? Pretty easy to waste the time, isn't it? Yeah.
He goes for the programming courses, he goes, he just asked you for the function.
Write the function.
Well, then the second one, he goes, write a program that will read from this, blah, blah, blah. Well, that's not just a function. It's a whole damn program. But if it's long, but still.
Well, those answer portions.
Or you ask for a program going on.
Well, that's the problem is you know, he says write one that reads a grade output, whether it's a A, B, or C, and then you touch to a file, outputs your highest, your lowest, and then. Well, that's a lot more than one function.
Yeah, you need to actually have them. You should have them.
But the way he looks at it, he's like, oh no, you can do all that in one function.
When you can.
That's what he'll say. He'll be like, that's one function.
But I didn't do it that way. He said write a program.
Just fold the corner over.
So how are you going to grade it?
Because
So what I did was I wrote it in Visual Studio.
He let you do that. Wait, did you take it in the test?
So you might have to
Okay,
print them all
that's
out.
why. That's why, because when you take it in the test center, they will grill you for opening up Notepad. You're not allowed to open up anything, yeah. To type, like you have to type in that little text box, it almost you do anything. It's not fun. They like go in there and they're like, no, you're not allowed to.
Oh, no, yeah.
It's sad.
That's
Like, how am I supposed to write a program?
Yeah, I know. It's like, you have an editor for a reason.
Yeah, you're sure.
Well, you usually sit in the bathroom.
I got graded. Or during midterm. Last semester, I was in computer science.
Yes, which has
Apparently, I'm still signed up for it, so I kept getting these emails like, "Please sign right." And then finally, I'm like, "I'm sure Laura got it." And then right now, it's like, you received a 0.
This is a new
Really?
Oh, I thought it was.
Looks like well, it's
Probably gonna have to talk to somebody about
Well,
that.
it's not due until.
Just the right hour. But, I'm sorry, Frank. I apologize. It's
I don't
fine.
know.
It sort of looks like
Sorry,
your handwriting.
maybe I'm so
Yeah.
onto the old architect. All of his days were old.
He did that on the exam
2 years ago.
Well, I write you
All
an
of them
exam.
do so like due 2014. That's
Weren't you in like first grade ever? And like the first thing they taught you was put your name in the upper right hand corner. Didn't they ever do that?
I was actually in high school when I started doing it.
Really?
I like
I did that.
Whatever. I mean, on the paper somewhere.
I forgot my name. That wasn't fun. She didn't take off pens for it, but she was like,
That's what I remember.
she like passed the aggressive and told me like, don't ever do that again. I was like, okay.
Don't do that again.
She said, don't ever do that again.
No, not nice. Well, okay, and whatever. She was.
Yeah.
Whichever one you raise. Now we're doing arrays. This is all arrays.
This is the problem with our country and obesity.
They want people to get thin in the country and they use fat U's.
No comment.
So much.
anticipating.
So
Yeah,
much.
I know.
No, it's, I'm just happy, 'cause my next class, I don't have to.
Good for you. My next class is tomorrow at 10 a.m., so I guess I'm kind of happy. It's actually, we just started a new semester for term 2, so all new students.
Which class is that?
It's Math 024. Yeah, well, thank you, sir. So we learn about exponent rules and polynomials.
Can I bring that?
I need to take
Good.
that, I need to take that according,
Anyone's welcome to sit in it. No problem, it's free of charge.
You know, when I was taking differential equations, because it had been, before I started my math here, it had been like.
Okay guys, so what we're going to do is we're going to move into the next part of the course where we're moving away from any sort of direct proofs or proof by induction. And we're going to start learning about sets, set theory, proofs with sets, but they might not be into the detail of what we did already. And then the other part of this section is learning about counting methods, okay, which most students do really well with, okay? So I think what's left in the course, just to kind of give you guys a heads up as to how much stuff is left in the course, I think we have 5 assignments left, 8, 9, 10, 11, 12, 13, or 12. So that's about 100 points at most you can get left. There's 2 exams left, which are each worth 100 points. The final's cumulative, and then there's another test that's non-cumulative before that. So basically there's about 300 points
Two
left.
exams or one exam and final?
Yep. So we have 1 exam and then 1
For
final.
final.
I count the final as the same weight as a regular exam.
Okay.
Okay. So just to let you guys know what's left in the course. So basically, I guess about 60% of the course is written in stone at this point, and then there's 40% left. So there's a lot of time to improve. There's a lot of time to screw up. I guess that's what I'm saying. So hopefully we do the other way and not screw stuff up. So.
How, like, is the rest of the stuff that we're learning, is it just gonna get more difficult?
No, and somebody else asked me this earlier, but the way I think about it is exam 2 by far is the hardest exam, okay? I think exam 3 is somewhere between exam 1 and 2, okay? So it's not ridiculously easy like exam 1 stuff is, where everyone got an A or B, but it's not as tough as the other one. So, so I don't know if that helps or hurts, but maybe gauges it. So maybe that could talk to you about how much you can slack for the rest of the semester. All right, other questions, guys? Okay, so let's go ahead and start with some basic stuff. Let's talk about some of the sets and the set operators, and then of course if you guys have some questions, just let me know about stuff, okay? I'm going to assume that some of you guys have seen this stuff before, and then maybe some of you guys haven't, but I just want to talk about some of the different notations when it comes to sets, okay? So 2 of the most basic operations or set are intersection and union. Okay? Intersection basically means what's shared between 2 sets. Union basically means I take 2 sets and I smash them together. Okay? So basically union means everyone's together. Intersection means it has to be shared. Okay? Set difference means that everything that's in A but not in B. Okay? So basically I just cancel out stuff that's in B and keep stuff that's in A. Okay? We'll see plenty of examples of these. Okay? The complement of a set is basically everything in the universe, but that's going to be outside of the domain A. Okay, so basically, if I said females, okay, in this class, that means that all the males would lead in the class, and then that would be the complement of males. Okay, so complement basically means if you're a universe, all students in Math 216, then we could divide up the males and females, comp sci majors versus other majors, etc. Okay, sure. Subset, as you guys know, means that if A is a subset of B, every element in A must also be in B. Okay, so basically some shared stuff going on there. And then, basically, guys, this just means X is an element of A, means that if X is contained within a set. So, like I said, a lot of this stuff you probably already know, but if not, no big deal. Okay?
Just check between union and subset. So subset is sort of a check, because it says if true, if all elements, but...
Correct. This is an operation. This is a Boolean, either yes or no.
Got it.
Okay? So this just means, is it valid? This one is always valid. There's always an output for it. Okay, does that make sense?
Yeah.
Okay. All right, other questions, guys? Okay, let's just rip through some of these. They're fairly easy. Most of you guys will do really nicely with them. Okay, so let's say that we have a universe. Okay, so in our class, if we have U, just understand that as the universe, meaning basically the population. We have a set A, 3, 4, 5, 6, a set B, 3, 4, 5, 6, 7, 8, 9, 10, and a set C, 1, 2, 5, and 10. Okay? If I wanted to know what A intersect B is, okay? So what I do is I just look at set A, I look at set B. We need to close that so we can actually see what set B is. That might be helpful. Maybe not. Oh, great. So if somebody were to tell me, what do you guys think A intersect B would be? So, go ahead, Jake.
3, 4, 5, 6.
Okay. So basically set 3, 4, 5, 6. Okay. And notice that A and B both contain 3, 4, 5, and 6, but 7, 8, 9, 10 are only exclusive to B. Does that make sense to everybody, guys? Okay, probably stuff you guys have done a lot. If not, you can see how easy it is. A union C. Okay. Can somebody tell me what A union C would be in this case?
3, 4, 5, 6, 7, 8, 9, 10.
Okay. So,
No. 3, 4, 1, 2, 3, 4, 5, 6, 10.
1, 2, 3, 4, 5, 6, 10. Okay. I want you guys to notice that 5 is actually shared between A and C, but notice that we only list the element 5 one time. There's no repetition in elements, okay? So once it's stated, it's stated.
Does it have to be in numerical order?
No, it can be in whatever order it wants to be. Just like a sequence can be in whatever, or, I'm sorry, just a list of elements can be in whatever. Okay. B minus A.
Would be 7, 8, 9, 10.
Okay. So all we do for B minus A is we just cancel out stuff that's common between A and B, and then whatever's left over from there, it's good. So we just cross out 3, 4, 5, 6, and then we're left with 7, 8, 9, 10. Does that make sense to everybody, guys? Basically, whatever shared you cross out.
If you had A minus B there, then you wouldn't have anything after
That's
that.
correct. So guys, if I asked you what A minus B is, that would be the null set, okay? Which is a set anyway, okay? So when we talk about sets, there's always an output for a set operation.
How do you write the nulls?
A couple ways. You could either write it like this, to where you just have the squigglies empty, or you could just write the 0 with the slash through it, okay?
I didn't get you. Why B minus A is 7, 8, 9, 3, but why is the other one not?
So, because let's say you start with A, okay? So A minus B means that you cancel out stuff. So you would cancel out, if this was A minus B, I'll erase this, you would cancel out 3, 4, 5, and 6, right? So that means that A would be left with nothing in there if it was A minus B.
Ah, okay.
But B minus A, you would have 7, 8, 9, and 10 left over, okay? It's not commutative, okay? So you can't flip the order back and forth and get the same output, okay? All right, other questions, guys, about this? Okay, A minus C. So we start with A. Let me erase this cross-out stuff. So if I started with A, which was 3, 4, 5, 6, and I canceled out the stuff that was common with C, all right, what would be left over for A? So, take on 3, 4, and 6. The only thing we cancel out is 5, right? So, A minus C means that the only thing between common, or that's in common, is just the 5. So we cancel those out, so it would be 3, 4, 6. Does that make sense to everybody, guys? Not meant to be difficult. If I had B minus the universe, okay, what's B minus universe for this, guys?
No.
It would be null
No.
set. In fact, what's anything minus the universe, guys?
Null.
Null set, right? Anytime you subtract the universe, it's always going to be a null set. We could prove that, but we're not going to, okay? So we would just say that it's equal to the null set. Okay, nice and easy, right, guys? Okay. A complement, everything that's in the universe, but not in A. Okay? So does somebody think they might know, or can somebody tell me what A complement might be?
1, 2,
Uh-huh.
7, 8, 9,
7,
10.
8, 9, 10, 11, 12. Good. Good. Does that make sense to everybody, guys? Basically, your universe is what you start with. That's basically your domain. If you wanted to think of a functional analysis, universe and domain are interchangeable. And then you just cancel out the stuff that's common, or that's not common. C complement.
4, 4, 6, 7, 8, 9.
Yeah. So we have, one more time. 3, 4, 6. Yep. 6, 7, 8, 9, 11, 12, right? Okay. Sorry. So literally, guys, on your next examination, I'll probably have like 2 or 3 of these worth 2 points apiece. Okay, they're really, really basic. Okay, but they are inclusive of set operations, so I want to make sure you guys are all okay with those. Any questions, guys, about this? Not meant to be difficult. A question that I asked you, and this is sort of what Andre said before, this isn't like this isn't necessarily going to always have an answer, it's a yes or no. So is A a subset of B, why or why not? So what would you guys think?
Yes.
Yes, it is, okay? So we would say yes. Okay. And of course we need some sort of justification. What's the justification,
They
guys?
share like
All
3.
values in there.
All X and A are also in B, right guys? So we could say for all X that are elements of A, X is also an element of B, right guys?
Can we just say all elements in A are?
Sure,
in B?
it's the same thing as I just wrote up there. I'm just a
Yeah,
little
I'm
bit
just saying
lazier.
like, I'm just being lazy.
No, that's just, no, actually I'm being lazy. Because if you actually wrote that out as a sentence, it would take longer than just to write the syntax or whatever, but that's okay. And then obviously guys, if I ask you part I, what would you guys say for that?
No.
That's false. And all we just need is one counterexample, right? Because remember, to be able to prove a universal statement, you just have to do exhaustion, which we clearly can
Which
see.
is 7.
Yeah, we could just use 7 as a counterexample, right guys? All we need is just one element, okay? So we would say no. And the reason is because 7 is an element of B, but 7 is not an element of A. Or you could just say, 7's in B, but 7's not in A. Okay, that might work out nicely. Okay? Guys, any questions about these? Okay, like I said, most of you guys have probably seen these somewhere along the line. Okay? You might not have seen the set difference, you might not have seen the complement. Okay? I'm almost assuming everyone's seen union and intersection before, but if not, okay, I just want to make sure you guys understand it's not true. Alright, so let's talk about some of these other types of problems, again involving justification of a subset or element stuff. Okay? So, is 13 a subset of ZI?
Yes.
No, that's absolutely false. That's not a set. 13 is not a set. Do I see squiggly brackets around 13? I don't see them. Okay? That is not a set. That is an element. So, this is false. See, you guys think you know everything. You know everything. Right? That is false. Okay? 13 is an element. It is not a set. Okay? So, false. 13 is not a set. Okay? However, what about 13 is an element
That's
of
true.
ZI? That's true, right guys? So don't be so quick to make sure, or don't be so quick to assume that you know everything with the set stuff, okay? Make sure you look at the syntax of it, okay? It's very, very crucial that you guys do that, okay? And I'm not trying to insult you guys, I just want to make sure you guys remember that and don't do it again, okay? So that's true, okay? And just because it is what it is. We don't have to justify true for this, okay? So on the homework, guys, if it's true, you just write true. You don't need to write anything, okay? Is 13 in squiggly brackets a subset of ZI? Yeah, that's true. Okay, so this is true. There we go. Good stuff, guys. Okay. Now be careful with this one, okay? Letter D. Is 13 in squigglies a subset of set 13, set 14, set 15, set 16?
No.
It is not. Okay, so that is false. Okay. What would make that true, guys?
If it is only 13,
Well, no, if it was only 13, it would definitely not be true.
If you put another set of brackets around.
Another squiggly around it, okay? Because it would have to be set 13, okay? Basically, guys, another way to make this true is if you said set 13 is an element of that, right, guys?
Yeah.
Okay?
Or
So-
if there was, each number didn't have its own.
Right, if it was only 13, 14, 15, 16. There's other ways to make it true, but unfortunately that one's going to be false, is because set 13 is actually an element of this set. Okay? So now we kind of start getting into the idea of what's the difference between an element and a set. Okay, that's basically what these problems come down to. Okay, so just be really careful, guys, with these. Okay, does everyone understand though why it's not a subset of that? It's only because we don't have the double squigglies. Okay, we need those. So if I asked you in letter E, is set 13 a subset of 13, 14, 15, 16? What would you guys tell me for that? That is true. Okay. So this guy's true. We don't need a reason for that because it's true. It just is what it is. Okay. In fact, James, I think he just said that, right?
Yeah.
So
I mean, it's built down though.
that's okay. All right. I think we've already answered this one as well for F. Okay. What do we think about set 13? Is that a subset of set 13, set 14, set 15, set 2? Yeah, it is. Okay. So this one's true. Is set 13 an element of set 13, set 14, set 15, set 16?
Yes.
Yeah, that's true, right? Guys, when it's an element, it means it must look exactly like what's inside it. Okay, so this will be true. Okay. This guy's missing a squiggly, so if you guys would be so kind as to fill in the squiggly right there. Sorry about that. Okay. And then the last question we have is 13 an element of set 13, set 14, set 15? It is not. It has to look identical to what's in there, and it does not. So false. Okay. 13 would be an element of 13, 14, 15, 16. Okay. But not set 13, etc. Okay. All right. So let me give you guys a minute to copy those down, okay? But everyone is aware of like the level of parentheses, okay, and the level of brackets and all that stuff. That's all we have to be cognizant of this, okay? Other than that, it's pretty easy once you start getting the hang of it, okay? So remember, for an element, it has to look exactly like what's inside there. For it to be a subset, it has one more level of parentheses than what's inside there. That might be a way to think about it. Okay. All right, guys. Let's just go ahead and do some stuff with the sets of numbers that we already know, our integers, wholes, rationals, etc. Okay. So let's say for some reason I let U be all integers, I let A be wholes, B be naturals, C be odd, D be evens. Okay. Let's answer the following in terms of universe A, B, C, D, if possible. Okay. So if we can, we will. If we can't, we can't. Okay. So if I took the odd integers and subtracted out the even integers, okay? What would I have left? The odd integers, which would be what? C. So this would be equal to C, okay? So does that make sense to everybody, guys? When I say answer in terms of A, B, C, D, U, that's what I mean, okay? If I have the whole numbers and I intersect that with the natural numbers, okay? Now that one we can't necessarily do a set for, but what would I be left with? A intersect B.
Natural
Oh, no,
numbers.
I lied. I'm sorry.
That's natural numbers.
Yeah, that would be the natural numbers, right? In fact, guys, anybody remember what's the difference between whole and natural?
Counting numbers. Natural numbers are the counting numbers.
Right. What does whole
Zero,
numbers have
zero.
that natural doesn't?
Zero.
Zero, right? So basically, A intersect B would be the natural numbers. Okay. So remember, whole numbers start at 0, natural numbers start at 1. Okay. If you don't remember that, I think a long time ago we wrote that in our notes. So go back when we were defining sets and look those up.
So natural numbers doesn't have zero.
That's correct.
Wouldn't it be, if A's intersecting B, wouldn't it be whole numbers then?
No, that would be the union between those. When we say intersect, it has to be in both sets. Okay? But Greg, you're foreseeing into the future, maybe about 5 seconds, because A union B is set A. Okay? So does that make sense now? I think you were thinking the other way.
I was.
That's okay. So just don't do that on the test, and you'll be fine. And then the following, or the final one we have, universe minus the whole numbers, okay? This one might be tricky for us to be able to put in terms of one of those, but anybody think they might know? Well, let's say, what's it equal to first of all?
Rational numbers?
Not rationals, but negative integers and probably, well, since we're subtracting a whole number. No, you're right, it's negative integers. So couldn't we do what, U minus? You're right, sorry about that, John. I thought we were subtracting out naturals. But yeah, that would be U minus if you wanted to write it. You could just write out negative integers if you wanted to. Okay. Does that make sense, guys? Like trying to write sets in terms of the other sets that exist. Okay. Just to remind you, and I'll write this out. Okay, you can just write this off on the side. But whole numbers, 0, 1, 2, 3, da 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 da. Natural numbers, 1, 2, 3. So that way when you guys go home and do your homework, you guys remember how to do that stuff. Integers are -2, well, dot, dot, dot. -2, -1, 0, 1, 2. There we go. Okay. So just in case you guys forgot about the sets, okay, that would be the roster form of those sets, so that way you guys can write those out. All right, so no questions about set stuff, guys. Anything I can answer about those? Okay. Now, unfortunately, okay, now that we know the preliminaries about sets, unfortunately now we have to start proving some stuff with regard to sets. Okay, so the only rules that we're going to have available to us are these things called the procedural definitions. Sometimes they're called the axiomatic definitions of sets. I don't know if you guys know what an axiom is, but an axiom in mathematics is something so fundamental that we just accept it. We can't even prove it. Okay. Like, for instance, an axiom that everybody in this class understands is the number 1, okay? We define a singular element as 1 for anything. It just is what it is, okay? So that's an axiom. It's so low level and so fundamental, we just assume it true, okay? Which is different than something like a lemma or a conjecture or something like that. A lemma is something that we can't disprove, but we can't necessarily prove as well, okay? So it's just that we don't have the capabilities yet, okay? And then theorems are things that we can easily prove, okay, or just prove, let's just say that. So yeah, you guys have probably heard those terms used, right? Lemmas, theorems, conjectures, you know, axioms, those sorts of things. So there are subtle differences between them. So I mean, I don't care if you guys know them or not. I mean, I do, but I don't. So anyway, so I want to go ahead and show you guys how we can use these procedural definitions, okay? And these, again, these are so fundamental that we accept them as true, okay? If we have the union between two sets, x is in A or x is in B, if we have the intersection between two sets, x is in A and x is in B, set difference means that it's in A, but at the same time it's not in B, and then the complement means that every element x is not in A. Okay? And by the way, x is just some element in the universe. Okay? So let's define what x is as well. X is some element in the universe. All right. Now, to be able to prove that two sets are equal to one another, okay? And we're just saying that, I mean, it'd be obviously easy to do if they were finite sets, okay? But if they're just some theoretical sets, what we would have to do is we would have to show that each of the sets are subsets of one another. That's how you prove that two sets are equal to one another. Okay? Which method of proof that we know of already might be helpful to show that these two conditions might be true? By cases. Nice, Ryan. Guys, if we can prove this by case 1, showing that A is a subset of B, and showing that B is a subset of A in case 2, then we'd be good with this. Okay? So it's not like some of the things that we've done already are going away. It's just we're going to approach them now from a set standpoint. And I know you guys are thrilled to do proof by division into cases, but unfortunately we're going to have to suffer through it. Okay? So all we have at our disposal are going to be our procedural definitions. We can also use some of the rules of logic as well. So remember we had at the beginning of the course we had those Boolean rules of logic, and we've already proven all of those. Okay? So we can use them as well. Okay? So we can also use, I'm going to write at the top, the logic rules as well. Okay. So let's go ahead and prove something very, very basic. By the way, these are actually equivalent to some of those rules we were doing with the Boolean rules. Like for instance, we proved I'm trying to think of what we proved using truth tables in class. We probably proved De Morgan's rule, or we proved something like that. Okay, or you could prove it using a truth table. That's actually what we're doing right now, is we're proving the most elementary of the set methods, so that way later we can use more stuff for sets. All right, so let's say we have a set, or two sets A and B. Okay, I want to prove basically a commutative property. If A is intersected with B, it's the same as B intersected A. Okay, let's define A and B to be arbitrary but particular sets, and let's let X be some element in the universe. Okay, so that's how we can start these out. Okay, so let's let A and B be sets. Doesn't matter what sets they are. They could be null sets. They could be everything that exists in the world. Okay, and let's let X be an element in the universe. Okay. And I'll put in brackets our favorite space uptaking thing, arbitrary or particular. By the way, guys, these proofs are very, very low level. Okay, so when we do these proofs, you probably, some of you guys are going to be thinking way higher than what's necessary with this stuff. Okay, go ahead, James.
Arbitrary but particular applies only to X there, right? Because saying B is a set.
Well, they could be arbitrary but particular sets as well. So like A could be like, if it wanted to be, A could be whatever set it wants to be. Okay, so when we say arbitrary but particular, we mean sets and elements as well. Okay? Because remember, we're trying to prove this true for all sets A and B, okay, no matter what. Does that make sense, sir? It's a good question, by the way. All right, case one. Now, I'm going to write out what case one is we're trying to prove. What we're trying to show is we're trying to show that A intersect B is a subset of B intersect A. Okay? Because remember, what we said before, when we're trying to prove two sets are equal, we need to show that one set is a subset of the other, and then the other is a subset of the first. Okay. We already know A and B are sets. Okay. So we can say A intersect B is equal, and guys, don't we already know by procedural definition that this is equal to, or I'm sorry, stop that. We're going to say, let's let X be an element of A intersect B. I apologize. So we're just assuming that X is just some element in the set A intersect B. Okay. Can we use the procedural definition? Okay, so we can say by procedural definition, in other words, one of those definitions up top, couldn't we say that X is an element of A and X is an element of B? And that's the definition that we just used, okay? So this is the definition that we're using right here, okay? And we said that that's fundamental, okay? We have to assume that that's true. Okay, so everyone's okay with that, guys? Not too difficult. Okay. Now, what I'm trying to eventually show is I'm eventually trying to show that X is an element of this guy right here, B intersect A. Okay? So, couldn't I flip the order of these around? Couldn't I say, thus, X is an element of B, and X is an element of A? So in other words, all I did was I just flipped around the order in which I presented the two sets. Okay. Now, what allows me to say that?
Commutative.
Commutative law of logic, right guys? Remember we had the logic law like way at the beginning of the course? In fact, if you guys have this sheet with the Boolean laws or the Boolean logical equivalencies, you guys would see that the first law that we have there, P and Q equals Q and P, that's why it's completely legal. So what you guys might want to do is try to resurrect this, because we're going to be using this on occasion to be able to prove stuff. Okay? And we've already proven all of these. Okay? So we're not using a set definition, we're using a logical definition. Okay? So we can just say, thus X is an element of B and X is an element of A by Boolean law of logic, or Boolean law commutative. Okay. Or you just say commutative law, whatever you want to do. Just make sure you say like the Boolean law of that. Okay. So is that okay with everybody, guys? Nobody doubts that. Well, since now we have X is an element of B and X is an element of A, couldn't we say that X is an element of what?
A and B.
Not A and B, but
B and A.
B and A, right? Because we just, I mean, we already know that it's X is an element of B, A and B, but X is an element now of B and A. Now, what allows me to say that, though?
That's the associative law.
Not associative, good try. We didn't move any parentheses around.
Procedural set definition.
Procedural definition, right? We're just going backwards from the procedural, okay? So let's look at the top, guys. This time we have X is an element of B and X is an element of A. We're just going backwards this time,
Okay.
aren't we, guys? And we're just saying, now we're going from right-hand side to left-hand side. Okay, nice job. So, thus, X is an element of B and A by the procedural definition. And we're done with case one. Because now that we've shown that for all X in A and B, X is also an element of B and A. Okay, or B intersect A. So we've done it. And like I said, it is extremely low level. Okay, so some of you guys are probably thinking like really high level of algebra stuff that we've been doing. Try to think low level with this stuff. Okay, it's almost like assembly programming. How many of you guys have suffered through assembly or are suffering? How low level is that stuff, guys? Like you have to define every single register that you utilize, right? It's extremely tedious sometimes, okay? So this is one of the reasons I do this, is just for those of you guys that are going through assembly, to try to make some of the connections with how low level it is. Okay, so we need a case two. So for case two, are we trying to show that B intersect A is a subset of A intersect B? How do you think you guys think we do that? Exactly like we just did the other one, except we just reverse all the A's and B's, okay? Usually, when you do this sort of thing with the axiomatic definitions, they're all the same. Once you get the first case down, usually the second case is about the same, okay? So let's just go ahead and write it out, okay? Not meant to be too difficult, okay? So we're going to let X be an element of B intersect A by the procedural definition, or axiomatic, whichever one you want to say. So by procedural definition, X is an element of B, and X is an element of A. We just used the Boolean law of logic, or the commutative law of Boolean algebra. Okay? So thus, X is an element of A, and X is an element of B by commutative law of Boolean logic. And then finally, we can just use the procedural definition once again and say, thus, X is an element of A intersect B by our procedural definition. Okay. So, very, very low level stuff, okay? But that's how we have to prove these sets, these initial set, I guess theorems what we're working with, okay? So, sort of like when we prove things with the truth tables initially with Boolean logic, we're doing the same thing here with just basically using the Boolean logic to prove that. So it's almost like an evolution of what we're doing. All right, so guys, this proof would get us 9 out of 10 points. What's the only other thing we'd have to do to get all 10
That's by
points?
case 1 and case
Yep,
2.
case 1, case 2, the result is true. Okay, so therefore, by case 1 and case 2, A intersect B is indeed equal to B intersect A. Okay, we already knew that, okay? But now we finally got to prove that's true. So, let me give you guys a moment to copy all that down, okay? And then a chance to ask me some questions that you guys might have. Anything I can answer, guys, involving this one? Okay, like I said, pretty low level stuff. And when I say low level, I don't mean it's easy. You just have to dumb yourself down. Okay? Well, Donnie, that's not a problem, is it? Sorry, I had to say it. So. Well, you're just so tired you don't even want to insult me back. Jeez. God, you're lame. All right. A more difficult proof. Okay? This is the absorption law. Okay? So I want to prove that if I have sets A and B, that if I have A intersect A union B, that's equal to A. Okay? Now this is an example of a proof to where case 1 and case 2 are not the same. Okay? One of the cases is extremely easy. The other case you kind of have to pull something out of the blue. Okay? So I'm going to show you guys what I mean by this. Okay? So just like we did before, let's let A and B be any sets. So let's let A and B be sets. And let's let X be an element in the universe. And then we can say arbitrary or particular if we choose to. So arbitrary but Case 1 is extremely easy. Okay, case 2 involves a lot of foresight. Okay, so let's do the easy case first. Case 1, what I'm trying to show is that A intersect A union B is an element, or is a subset, sorry, of A. So, all we have to do, we're just going to let X be an element of A intersect A union B. That's easy enough. That's how we always start these types of proofs. We just say, let's let X be an element of the right hand or the left hand side. What do you guys think might be a good next step to be able to try to go forth with this? Well, what's the only thing we know how to do with sets?
Can you like separate them like A and A, then B, like what is that called? That forgot the name. Like,
Are you talking about like a distributive property?
yeah, distributed.
Well, we don't know that yet, though. We can't prove that. Okay.
Oh, it's not just say that means X is an element of A and
Yes.
X is an element of A union B.
Use the procedural definitions. Correct. Okay. Or were you talking about like saying A and A or A and B? We can't do that yet. We haven't proven that. Okay. If we did prove that, then yeah, we could. Okay. So, but James, I like your idea. Let's use the procedural definitions. Guys, first thing you do is you say X is an element on the left side, then you always use your procedural definitions. It's the only way we can go with this. Okay, so by procedural definition, we can say that this means that X is an element of A and X is an element of A or
B.
X is an element of B. Okay, and I'm going to put this in parentheses. Okay. All right. Now let's think about this. I think we're done with this because I've told you that X is an element of A and X is an element of A or B, right? Well, what do we want, guys? What are we ultimately trying to show? X is an element of A. I'm telling you that X is an element of A and X is an element of B. Okay. I have blue marker and black marker. I have blue marker and black marker, right? Which one do I usually write with? Black marker. So I pick black marker. With an and statement, I can pick either one of these that I want. I'm just going to pick A. That's the definition of an intersection between, okay, or the definition of a conjunction. Okay, so we could say thus. Now this only works for an and. So thus, X is an element of A. Okay, and we could say that's the definition So with an and, like I said, it only works for ands. If you have or, you can't do that. Okay? Because on your homework, you're going to have an or, and some of you guys are going to try to do that with an or, and you can't do that. Okay? So, does that make sense to everybody, guys? If you have two things, if you have one thing and another thing, you can pick whichever one you want. Okay? It doesn't matter which one. Okay? Well, guys, we're done. Okay? We've already shown that X is now an element of A, and we have our subset done. So if X is an element of this, then X is definitely an element of X is an element of A. Okay? Does that make sense, guys? Any questions about that? Okay? All right, so let's do the other one. The other one's a lot tougher. You have to be sneaky with this one. Okay, so case 2. Now this is why it's tough. We are trying to show that A is a subset of A and A or B, right guys? And this is why this one's so tricky, okay? What's the first line that you guys are going to write in this proof, or for this case 2? Let X be an element of A. You always start by letting X be an element of the left-hand side. Why is that tough to do anything with? There's no definitions. There's no set operations. There's no procedural definitions. I mean, that's just saying, let's start out with the number 1. Not even 1 plus 1. Because if I gave you 1 plus 1, you'd know what to do. But if I just put a 1 on the board and said to do that, you guys would have no idea because there's no operator there. Okay? We are ultimately trying to show that X is an element of A and A union B, right? Now, we've already got the left-hand side. Everybody would agree with that, right? I already know X is an element of A. So all I have to do is somehow show that X is an element of A or B, right? So, let's play this game again. I always like to play the logic game, okay? In my hand, I have black marker or rattlesnake that's going to bite Paul in the face, okay? Which one do I have? Black marker, right? Thank God I don't have the rattlesnake, otherwise you'd be really pissed off at me, okay? Or you'd be running, and then be pissed off at me. In my hand, I have black marker or $3 million. In my hand, I have black marker or cure to cancer. In my hand, I have black marker and Art's hairs, okay? Wherever they went. I don't know, how long it's been since you've been bald? Too long?
Too long,
okay.
yeah.
What's the point that I'm saying, guys? As long as one of these is true, I can say or anything else, right? So, thus, X is an element of A, or X is an element of any other set I want it to be. Either life-threatening cobra, or it's lost follicles, whatever you might want to say. What do we want X to be an element in for this problem?
A or
B, right? We want X to be an element of B, okay? And I'm going to make a note that it could be an element of whatever set that we want it to be. We just pick B because that'll get us to A or B. Does that make sense to everybody, guys? If it's an or, you can pick whatever you want because that's not a lie, as long as the first part is true. And guys, this is true. We let X be an element of A. You have to suppose that that's true.
Oh, that's the generalization, specialization.
That's going to be generalization.
Yeah,
okay?
okay,
It's actually the definition of a disjunction. Okay? So it could be any set, and I'm going to write this here. This could be any set that we want it to be. Okay? As long as it's or. Can't do that with and. Okay? You cannot build X is an element of A and X is an element of B. Okay? So, guys, do we see these subtle definitions between ands and ors? Okay? If you have and, you can pick either one you want. You can build an or, okay, but you can't build an and. Okay? So try to keep that in mind when you guys are working with your homework. Okay? Well, guys, now can we just use the procedural definition? Okay? So, oh, by the way, we need a justification for this. So thus X is an element of A or B, okay? That's the definition of a disjunction. Okay, remember disjunction means or, conjunction means and. And then we can go ahead and we can just say, well, this is going to be our procedural definition. So So by procedural definition, X is an element of A union B. And guys, isn't it clear that X is an element of A, and also at the same time, X is an element of A or B? We've got both sides of this. We have X is an A and X is an A or B. Okay, so we're basically done with this. Okay, so thus, X is an element of A, and X is an element of A or B, as shown above. Okay, I mean, it's clear that we have both of those. Okay. And by procedural definition, we can just stick a union or an intersection in for the and. Okay, so, and one more time, by procedural definition, and by procedural definition, X is an element of A intersect A or B. And guys, we're done, okay? We've shown both case 1 and case 2 to be true, so that we can say by case 1 and case 2, we can say the absorption property for sets is valid. Okay? So we say, therefore, by case 1 and 2, A is indeed equal to A intersect A or B. Alright, so these are a little bit sneaky because sometimes you have to pull some stuff out of thin air. Okay? So make sure that you guys know the definition of conjunction and disjunction. Okay? Like we said, for conjunction, okay, and I'll write this up here, you guys don't have to write this down, it might be helpful, it might not be. But if X is an A, then X could be an A or X be in any set. So this is the disjunction rule. Blushing, sorry. So that's our disjunction rule. The conjunction rule says that if it's in both sets, so conjunction says that if X is in A and B, okay, or we could say, I'll put a backslash here. X is in A and X is in B. We could say one of two things. We could pick whatever we want. We could say X is in A. We could say X is in B. Okay, either of those would be true. Okay, so that's a definition of a conjunction. Disjunction, we can build one. Conjunction, we can take either one or both if we wanted to. Okay, not necessarily, but it's not necessarily that we have to. Does that make sense, guys, for the difference now between disjunction and conjunction? Any questions about that, guys? Okay. Hopefully it makes sense to you guys just logically, okay? But if not, make sure you guys come and see me or email me so I can help you guys out with that. Okay. So, now that we've proven a couple of these using the procedural definitions, and you guys can see how painful they are, okay? Remember what we did in class was we might have proven like one or two of the Boolean laws using the truth tables. Now we're going to be able to prove more difficult stuff using properties of sets. Okay? So much like when you guys had the Boolean stuff, okay, I'm going to give you guys a sheet with all the properties of sets on there. Let me hand that out real quick. I probably should have handed it out at the beginning, but there might be 8 in here, but if not, sorry about it. You can just guess. There's a whole bunch in here. Yep, they're not all yours, by the way. You have to share it. Okay, so I'll wait till everyone gets a copy of this. And then we'll go ahead and work some examples involving the set law stuff. By the way, a lot of these are going to follow the same sort of stuff that we did with the Boolean algebra. So for those of you guys that were really good with your Boolean algebra, this should be fairly easy to work with. Okay? But if you're not good with the Boolean algebra, then this might be a time for you to either A, get better, or B, get more frustrated with it. I'm not sure which one you'll hit, but hopefully one of the two of the good types. Okay, so we can use any of these properties now to be able to prove if I say using set laws. Okay, so I'm going to ask you guys to prove using the procedural definitions like we just did, and then I'm also going to ask you guys to do the set laws. Okay, so let's go ahead and take a look at a few of those. Okay, so using the set laws, I want to prove that for any sets A and B, that A union set difference B minus A is equal to A or B. Okay, so the way that I look at these is, anytime you have a set difference law, use the set difference law immediately. Okay, I mean, you get a 1 point on the exam just for using set difference. It's the easiest one to do. Okay, so by set difference law, this is going to become A union quantity B intersect A complement. Okay, that's going to be equal to A. Okay, so that's just our set difference law. So does everybody see that, guys? It's rule number 12. If you have B minus A, that becomes B and A complement. So in this case, I just have to put the A in here. Okay, so that's our set difference law. Eventually, we want to make it look like A or B. Okay, so does anyone think they might have a suggestion for a law that we can use at this point? Bless you, Ben. And the good news is you have a 1 in 12 shot of getting it right, which is roughly an 8.3% chance. Distributive, yeah. Guys, take a look at your distributive law. If you, and remember when we talked about Boolean algebra, if you have alternating signs, probably distributive is going to be the way to go. So this is exactly what the very first distributive law says. A or B and C, so we have A or B and A complement. So let's just make that work out with the distributive law. Okay, so isn't that going to be equal to, well, maybe somebody can tell me, what's that going to equal to? A union B. So A union, what was it?
Complement.
A complement, nice. And then what goes in between here, guys? Intersect or union? Intersect, nice. There we go. So, and that's going to be equal to A or B, hopefully. And that's by our distributive property. So does that make sense to everybody, guys? We have alternating symbols there, okay? And that's probably the easiest way to think of when do you use distributive versus associative. If they were all intersects, you could use associative, which would be really nice. Since one of them's a union and one of them's intersect, we have to flip those around. Okay. I'm hoping the next step is really obvious. Donnie, do you
I
have
just
that?
had a quick question.
Yeah.
The thing with the power, see, that just means anything that's not in A?
Correct, that's complement, right. So that just stands for everything that's not in A. Okay? Alright, so take a look at your list now, guys. Okay, hopefully this was really obvious. But if you have A union A complement, what's that going to be equal to?
Universe.
The universe, right? If I have whatever's in A and not in A, or I'm sorry, or not in A, that means I have the universe. And that's the complement law, isn't it, guys? Take a look at rule number 5. It spells it out specifically. A union A complement is universe. Okay, so this would become A union B intersect. Now here's what I'm going to do, guys. I know my U's and my unions look alike. So anytime I wanted to know universe, okay, I'm just going to put like the smiley face, like the McDonald's smiley or whatever it is, so that way you guys know I'm dealing with the universe and not the union between two sets. Okay, and I'll make sure I specifically do that each time. Okay, so that's going to be our complement law. Okay. I think we're just one away from being done this. Okay. Is there anything that says if you have a set and the universe, what that equals to? And if so, what is it? What's that going to boil down to? Yeah, guys, take a look at the identity law. Okay, if you have a set and a universe, so we have set and universe, it's equal to that set, right? In fact, we actually did those types of problems earlier when we did like the integers and the wholes and the reals and that sort of stuff. Okay, so this just becomes A union B, which is equal to A union B, and that's our identity law. sense to everybody, guys? Any questions? Great.
Well, just a comment, I guess, rather. So because it's A or B is I don't want to use the right. So because
That's all right.
it's the intersection between A union B, between that and the universe, because the universe holds everything.
Correct.
You only need to keep that.
Correct, right. So this just means that, and you were talking about this, Greg, or?
Oh, no, I was talking about that stuff.
Okay, yeah.
From complement to identity.
Gotcha, okay, yeah, because it means that, okay, well, if you have like a couple elements, and you want to intersect them in the universe, you're not really losing anything.
You just keep those couple
So you just keep that set, right. Okay, so that's what we mean by our intersection. Okay, John?
Do we not have to do like let A be equal set?
No, that's for the procedural definition, okay? Basically, John, what we did was we actually proved one of the commutative laws, and then we actually proved one of the absorption laws, okay? You would the only time you would use the procedural definitions is to prove any of these, okay? So, and on the examination, and a couple for homework, I'm going to say prove one of these laws using the procedural definition. Unless I say procedural or axiomatic, don't use that stuff. You would be here a very, very long time trying to use procedural or axiomatic doing that stuff, okay? Yeah, we don't want to do that, we don't have to. Okay. Other questions, guys? Okay, let's take a look at another one. Okay. A little more difficult, okay? If I had A minus B minus C, that's equal to A minus B union C, or hopefully it is. Okay. So, just like we did before, guys, what law do you think we should start with because there's minuses in there? Set difference, okay? We gotta do that. Well, we don't have to, we did. So by set difference.
Chris.
Yes, sir.
Instead of set difference, because A has to be there, so why don't you do like A associative and then do the set difference?
Can't do that there, because if you look at our sheet, we don't have an associative law that has to do with minus symbols,
got it.
okay? So now eventually we could, okay, but not yet. We have to turn it into the intersect and the union symbols. Okay? So you're on the right track of thinking about it. I like how you're thinking about it. So this would be A intersect B complement, intersect C complement is equal to the right-hand side. Okay, so that's just going to be our set difference. Okay. Mr. Art, can we use an associative now, sir?
Yeah.
Yes, we can. Okay. We don't want to use distributive law because we're not using alternating symbols, okay? Now we just have an intersect and an intersect. So let's just move those parentheses around. Okay, so this would be A intersect quantity, B complement intersect C complement. Okay, that's just our associative property. I know most people think the associative property is just one of those that you can always just assume and not write it out, but this one is extremely important that we do write it down. Okay. All right. Anybody have an idea? And remember, we're trying to make it look like A minus B union C. Okay. So, anybody have an idea as to perhaps what we could do with this? So, go ahead, Jake. Yeah, De Morgan's law. In fact, we use like reverse De Morgan's, right? We'd almost factor that complement out. Okay, so Jake, what would that look like, sir? A intersect quantity what?
B intersect C complement.
And sir, instead of intersect, do you mind if I make it a union? Because we have to flip it around. Nice. So, that would be A intersect B union C complement. Good job. And that's going to be equal to, hopefully, the right-hand side. Okay, so that's our De Morgan's law. Basically, we just factored it out. Yeah, set difference, right? Aren't we done? Because we have A intersect something complement. So anytime you have intersect complement, that's the very definition of what the set difference is. Okay? So John, would you write it as A minus the quantity of B union C? Again, guys, anytime that you have intersect complement, okay, all you guys have to do is just change that into set difference law. That's all that is. Okay, so this is our set difference. I think we're done, right? Because this left-hand side now looks identical to the right-hand side. So these first couple, like I said, if you're good with the Boolean algebra stuff, this actually follows the exact same. Okay, but if you're not good with the Boolean algebra, then unfortunately it's a little bit tougher. Okay, go ahead, Ray.
Use these on the examination? or-
Yes. Yeah, just like with the Boolean laws, you guys are certainly allowed to use that as long as you don't write anything on there that would be beneficial. Okay. All right, other questions, guys? Okay, the next one is much more difficult than the first two, and I probably need about 15 minutes to do that, and I do have to return your guys' examinations, so let's stop here. I'm going to return the examinations to you guys, and that way if you guys need to ask me any questions about anything, you can, okay? If you guys want to, you can do almost everything on assignment 9. So what I might do is, if you guys get some time, I'm sorry, assignment number 8. It'd be tough to do assignment 9 since we haven't learned anything on that. But assignment number 8, you guys can do almost all the problems. There's probably that last one that's going to be really difficult, so don't do that one yet. But that's going to be due next Monday. And is that the 31st?
Yeah.
Yeah, it's Halloween. Okay. Great. I'll come in as a scary math teacher. Okay. Alright, so I do have your guys' examinations, but I didn't return, I think it was assignment number 6. So let me give all those back to you guys. Just in case you're curious about the grade distribution for this, 6 A's, there were 8 B's, there were 2 C's, there were 4 D's, and there were 5 F's. So very bimodal distribution as opposed to the first examination, which was very skewed to the right. Okay, the average on the exam was 77.54 exactly, which is difficult to get an exact. But since there's 25 people in the class, it makes it really nice to divide by. So the standard deviation was actually around 10 as well, which is a really high deviation. So, just in case anybody cares about any of that stuff. Okay, the first exam I didn't even put it out because everyone got easy. So. Okay, so let me give these back, and then if you have some questions for me, let me know.